we are going to fill out this entire unit circle. On your slide, on your notes there, I put this on here so that I had this to look at. You probably want to use the separate sheets, right? If you have not, I told you guys yesterday you could go ahead and start putting first quadrant on here if you wanted. But we need to fill out the whole thing. You don't really have room on that slide. I just wanted to put it up here so I can fill it in up here and you can transfer that there. So you will need this sheet right here. And it is going to look terrifying whenever we get it finished. It's going to have all kinds of crazy stuff on it, and it's going to look terrifying. But there are a lot of this that you don't actually have to have memorized. Okay? So, first of all, let's fill in these two little blanks right here. For positive angles, which direction do you go in? Left could be subjective, counterclockwise. Which will look like that. And for negative angles, you're going to go the clockwise direction. So that would be like this. So what we learned with like our coterminal angles and whatnot, that's still true for the unit circle. So that is going to apply to this stuff. So we'll fill that in. All right, so let's talk about the unit circle. There are really only, so for the unit circle, whenever I grade this, there are 66 things that I'm going to grade on here. It's a bunch. But there are really only about 16 that you have to have memorized. The rest of them you're going to be able to figure out from the other pieces. Okay? So, first of all, and I did it wrong on this work on your notes, so we'll fix it in a second. But on those first two lines, right, x should be your cosine of theta, cosine of your angle. And y is sine of theta, sine of your angle. So that's your first two blanks. You'll have to have that memorized. Okay? So you need to know that x is cosine, y is sine. Okay? So we'll have that on our top two. Now, a lot of this, I'm going to start from scratch. Some of you already had your first quadrant filled in because we did that yesterday. I'm going to start from scratch because you are going to have, for unit circle, you're going to have 2 quizzes on unit circle. So tomorrow, we will have a quiz on using the unit circle, which we're not going to know how to do till the end of this. But second period was feeling pretty good about that, actually, by the time we got to the end of class. So using the unit circle, so tomorrow, once we get this paper filled out, you will be able to use that paper on tomorrow's quiz. So that unit circle right there, you can use it on tomorrow's quiz. On Monday, we are going to have another quiz where I'm going to give you a blank unit circle. It's going to be on paper. It'll be about the only on-paper quiz we take the whole time. And I'm going to give you a blank version of that, and you're going to have to fill it in. Okay? So tomorrow, you do not have to have that unit circle memorized. On Monday, you are going to have it memorized where you can fill it in. Because we're getting really close to the end of the semester, and you cannot use that unit circle on the test. They're not going to give it to you. But what they do give to you on the test is they give you Desmos. And Desmos will give you a lot of the unit circle on its own. So let me show you how to get to that, okay? So if I go over to Desmos here, so if I go to Desmos right here, and let me make this bigger so you can see. So if I go to Desmos and I hit the wrench up here in the corner, right here it says grid, and there are 2 options. We have never changed that option right there, unless you just got curious one day. We haven't changed it. There's one that looks normal. There's this other one that looks kind of like a bullseye. So if you click on that one that looks like a bullseye, it gives you this. Okay? So right now, this is in radian mode. So this is giving you the radians of almost all of your pieces on the unit circle. So if you look at your unit circle that you have over there, let me split screen this, you will notice here that, like, notice how you got like a pretty big gap and then a shorter one and then a shorter one and then another big gap right here. So what you're seeing here, this first one right here, let me draw in the lines over here so you can see. This right here is this first line right here. This right here is this line right here. And then, of course, you've got, like, your horizontal is right here, and your vertical is right here on that. So that's what we're looking at for the unit circle. So these numbers, we can just pull off of that unit circle, right? We got 0 right here. We got pi over 6. We got pi over 3. We've got pi over 2. We can keep going around. So you don't really have to have these memorized because the state of North Carolina says you can use Desmos on your exam, and Miss Martin and I checked the other day on the NC test to make sure it did still do the same thing as Desmos, and it does. So you can just, if you just click over here and change it to this right here, you'll be able to get those values. So I will let you use that on Monday whenever you have to fill this in. You won't have to have that memorized because you can do that. You also can go over here and click to degree mode, and it'll change it to degrees. And then it'll give you all the degrees for that. So you can do that. So there's not much of the inside of the circle that you have to have memorized because you can pull most of it from Desmos. Okay? So I'm going to get rid of that, make this full screen, or you'll never be able to see what I'm doing here. So we had already done the other day. I'm going to fill in all the stuff you can get from Desmos first. You could just look at Desmos and fill this in. So on Monday when you have to fill in a blank one, I'll turn on class-wise. I'll focus you to Desmos where you can't get to anything else, and you can use it just to copy to the page. So you will have 0 degrees right here. You'll have 30 degrees right here. I'm going to skip this one because it's not going to be on Desmos. Then you'll have 60 degrees here, 90 degrees here. You'll have 120 degrees here, 150 degrees here, 180 degrees, 210 degrees, and you guys can go ahead and start filling this in on yours, 240 degrees, 270 degrees, 300 degrees, and 330 degrees. You know, so it's basically just going up by 30, right? 30, 60, 90, 120, 150, 180. So these are really not that hard to do without Desmos because you're just going up by 30. But you can use Desmos if you need it. Now, this does leave 1, 2, 3, 4 spots that you do not have with Desmos. So these will have to be memorized because you won't have them with Desmos. Although, this right here is halfway between 30 and 60, right? What number is halfway between 30 and 60? 45, right? So, although you do have to sort of have it memorized, it's not, like you can kind of figure it out, right? So this should be 45 degrees. This number is halfway between 120 and 125. That's going to be 135 degrees. This one is going to be 225 degrees, and this one is going to be 315 degrees. Everybody okay there? All right, so the other thing that we're going to need here is our radian measures. So we had already filled in radian measures for the first quadrant. We had 0 radians here. We had pi over 6 radians here. I'm going to skip this one right here for now because it was on, it's not on Desmos, so we'll add those in last. But that one is on your, I think we already did that one. This one is going to be pi over 3 radians. Right here we'll have pi over 2 radians. Right here we will have 2 pi over 3 radians. This one will be 5 pi over 6 radians. This one's just going to be pi radians. This one is 7 pi over 6 radians. This one is 4 pi over 3 radians. This one is 3 pi over 2 radians. This one is 5 pi over 3 radians. This one is 11 pi over 6 radians. Now, all of those can be pulled from Desmos. You don't have to have them memorized because you can pull them from Desmos. Because I know they seem a little crazy. There are a lot of reasonable mathematical reasons that they are what they are. For example, half of this circle is pi, so it makes sense that this one right here would be pi divided by 2, right? We're taking the half circle and we're dividing it by 2, right? These pi over 3, that's like a third of this half circle right there, but you're going to be able to get those from Desmos, so I'm not going to go into great detail on where exactly they come from. Yes? 5 pi over 3. Now, this does leave, again, 4 spots that we don't know. So, the 4 spots that we don't know are right here, right here, right here, and right here, right? The same ones that we did not know in degrees. Those are not going to show up on Desmos. So those you're going to have memorized, and they are pi over 4 radians. This one is 3 pi over 4 radians. This one is 5 pi over 4 radians. And this one is 7 pi over 4 radians. All of the ones that don't show up on Desmos are over 4, so that helps you remember that denominator, and they're going to go up by odd numbers, right? 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So those 8 pieces that I have highlighted there, you're going to have to memorize those. Everything else you can pull off of Desmos. Okay, here. So those are all of our angles on the inside, either in degree or radian mode. If it were up to me, and I still decided to teach this, I would only do degrees. But the state of North Carolina said I got to teach you both. So, so we got to do degrees and radians. Now, our first quadrant. Actually, let's stop. Let's not do first quadrant. Let's do these points right here. Let's do this point, this point, this point, and this point. The ones that are like 90-degree increments, right? So this is a circle that is graphed on the unit circle that has a radius of 1, right? So this right here, like if we're thinking about the coordinate plane, this right here, that's 1. This right here is 1. This right here is not 1. What is it? What? It's negative 1, right? Because right here's the point 0, 0. There's your 0, right? You go left 1 and up 0. And then this right here is also negative 1. So we're just thinking about like the coordinates of that point. The coordinates of this point right here, let's make it pink, that is 1, 0. Right? Because you would go over 1, you would go up 0. What are the coordinates of the top point right there, your 90-degree angle? 0, 1. What are the coordinates of the 180-degree? Negative 1, 0. And what are the coordinates of the bottom point here? 0, negative 1. So those don't necessarily have to be memorized. They're just like graphing those 4 points, right? So those are not necessarily memorized. The stuff here, let's see. I'm going to highlight before I write here. The stuff here in that first quadrant, that stuff has to be memorized. These you just got to know. So I showed you where it came from the other day because we did those triangles. And we could do one for every single place on this circle, but we are not going to do that. This one is square root. Ooh, hold on. Go back down to smaller. Square root of 3 over 2, 1/2. This is square root of 2 over 2 and square root of 2 over 2. And this one is 1/2 square root of 3 over 2. Okay, so basically those like 14 things that I have highlighted there, plus the x equals and y equals at the top, you have to have memorized. There's not really much way around it. I do have a trick. I'll show it to you tomorrow. We're just starting to use this, so I'm going to show it to you tomorrow to maybe help you with that first quadrant there. But that stuff must be memorized. The other stuff, so we still have several blanks around here. It can be figured out without memorizing because here in this first quadrant, both of my coordinates are positive, right? X coordinate and y coordinate are positive in the first quadrant. What is true in the second quadrant? X coordinate, is it positive or negative? Negative, and y coordinate is positive, right? Because you're going left and then you'll go up. All right. In third quadrant, what do we have? Negative, negative, and in fourth quadrant, positive, negative. Right? You don't necessarily have to write this on your unit circle, but if you do, it's fine. I'm not going to be grading for that. So that means if I take this point right here and I flip it over to this side, the x-coordinate is going to be the same value, but it's the other direction. So it's negative right there. And the y-coordinate is the same. It has not changed, right? So it stays the same. And then I'll have, this one will be square root of 2 over 2 and square root of 2 over 2. Except the x-coordinate needs to be negative. And then this point flips over here, 1/2 square root of 3 over 2, except x-coordinate needs to be negative. Alright, so I can do the same thing whenever I look down here. Basically, all of them closest to the x-axis are going to be square root of 3 over 2, 1/2, and square root of 3 over 2, 1/2. But in the third quadrant, both of them are negative. And in the fourth quadrant, just the y-coordinate is negative. And so the square root of 2's over 2's. We'll go here. And here, third quadrant, both of them are negative. Fourth quadrant, just the y-coordinate is negative. And finally, these closest to the y-axis, they're going to be 1/2 square root of 3 over 2. 1/2 square root of 3 over 2. And you'll have negative, negative right here, and over here you'll just have a negative. And remember, all of this is graphed on the coordinate plane. So the ones I see messed up most often are like these right here and these right here, because people get them backwards. They'll put square root of 3 over 2, 1/2, where they should have 1/2 square root of 3 over 2. So whenever you're doing this, think about, these are graphed on the coordinate plane. So like this point and this point right here, they are like on the same horizontal line. They should have the same y-coordinate, right? Their y's should be the same. When you look right here, I don't draw on this too much because I'll make it crazy looking. But like if we look at these 2 points, they should have the same y-coordinate. These 2 right here, they should have the same y-coordinate. These 2 right here should have the same y-coordinate. Like if you go straight across, those should have the same y-coordinate. X-coordinates will be flipped. The sign will be flipped because they're on opposite sides there. So this is the unit circle completely filled in. What I want you to do is make sure you've got it completely filled in. And then look at your neighbors and double check theirs. Because if your unit circle is wrong, you're going to mess up on both of the quizzes that are coming up. You need this to be correct. So look at your neighbors and make sure they've got all their signs right. I can see like right here, that one I meant for it to be negative, but it doesn't look like a negative. I'm going to go fix it, make sure it's clear that that one is a negative. So check and make sure that your neighbors is correct. Because if they're wrong, it'll be bad. If they're really wrong, it'll be really bad. If they're a little wrong, it'll be a little bad.
This whole thing looks really bad.
It looks scary, doesn't it? You really don't. Because yesterday, you can. But wait till we do what we're actually using this for. Because mostly what we did yesterday was building up like the understanding of where this comes from. But the truth is you don't really have to understand where it comes from to use it. So I think you will see once we start doing the problems for this that you might feel, I would love for you guys to all understand exactly where all this comes from. It's your triangles put on the circle, and that's where we get our x and y coordinates. But let's say that perhaps the things that we have been doing, like at the end of class yesterday and the beginning of class today, like did not make any sense to you. And this seems like a big, scary, torture device that math teachers just came up with to cause you guys anguish. It's not that hard to use. It's hard to understand where it came from, but the problems we're getting ready to do with it are not terribly difficult usually for most students. RAD is radians. It's your radian measure. So like when we were converting from degrees to radians, like you just did on that quiz, that's the same here for that.
Is 1, 2, 3, 30, 11, 5, or 6?
Yes. Yeah, 11 pi over
one on the quiz. Well, I missed a couple on this, but on the last one, I put a negative. I thought it was going to mess up. Negative.
But you got the right.
I got the right number.
I'll give you some points back for that. I'll give you some points back for that. I need to remember to go look at that. All right, so for the unit circle, there are two main reasons that we need. Well, there's three main reasons we need to know the unit circle. The first reason is because the state of North Carolina said that it is in our curriculum and we have to learn it for this class. And so that is what it is. The second reason that people would need to know the unit circle has become obsolete in the last several years. And that is because whenever you did not have calculators for trigonometry, this was very helpful. Now, the argument of, well, you may not always have a calculator with you is not a very good argument anymore. Even when I was like in school, teachers would say that. They would say, well, you might not always have a calculator. Certainly, we had tons of calculators. We had like handheld calculators, but not many people carried them around with them all the time because nobody had smartphones. But since the advent of the smartphone, where you can put Desmos on your smartphone, not just the little calculator, you can put Desmos on your smartphone. The argument of you're not going to have a calculator is kind of out the window now. What we're doing today is really looking at how this was useful without whenever there were no calculators for people to use. I know that seems like it is like ancient history. To me, it is incredible for me to think what a short amount of time calculators have existed. Whenever Jane Hendrick was in trigonometry in high school, she has told me she did not have a calculator at all to use. That means to do trig, if she wanted to know what sine of 35 degrees was, she had to have these big tables, and she had to go look up that sine of 35 degrees was 0.872, and then she had to use that value without a calculator to calculate whatever she was calculating. To me, like the idea of trying to do that, and it would take you 30 minutes to do one problem that would take us, 2 minutes to do now or less, right? So it's really not that long ago that people did not have calculators. They did exist before Miss Hendrick was in high school. Like calculators did exist, but they were not widely available. So schools did not have them. So we really have not had calculators very long. There are plenty of people alive today that did not have a calculator growing up at all. This is only recently became obsolete. Think about like the course of human history too. Isaac Newton and Gottfried Leibniz created calculus in the 1600s without a calculator, like 300 years before the first calculator was invented, which to me is just like crazy to think about. Like all of this because calculators make it so easy to do complicated, like to test a bunch of different ideas because you can do those calculations quickly. Whereas they would have had the tedious calculations for everything, and really looked at things like theoretically. So to me, that's just kind of crazy. But calculator, if you don't have a calculator, this becomes useful. Now, I will let you use the calculator, but the calculator is only going to give you decimal answers. And the calculator, like if you have a degree problem, you have to be in degree mode. If you're in radian problems, you have to be in radian mode. So it can be helpful, but it's not the primary way I want you to think about these. The other reason that we need to learn this, and this is the reason that really connects into like some application and some stuff you still need to know about this course. So the reason it's still here, even though we have calculators, is because really we're not going to get into this until tomorrow, but we can take these values right here and we can sort of like graph them out on the XY plane, and it is going to create, we'll see this tomorrow, it's going to create a graph that looks like this. And those graphs are incredibly useful for a lot of periodic things. If you're looking at looking at ocean tides, if you're looking at the amount of daylight, there's all kinds of places that those things apply. So there's a lot of usefulness to this, and this circle connects those things together. So that's why we've got to do it. But sometimes it's overwhelming whenever you first see it. So now, it is overwhelming to look at, but most of second period was feeling like it wasn't all that bad to actually do the problems, right? So let's look at what the problems are going to look like. So you guys have your unit circle. I'm going to flip over here. This is wrong. Well, actually, it's correct now, but it's wrong on your paper. So on where it says evaluating trig functions using the unit circle, Shay earned herself a bathroom pass during second period because it was incorrect. I think I gave it to you before you went, maybe. There's a possibility of it. It says 7.2.
Yeah,
Got it. Okay. All right. So, on your paper, it is incorrect. Sine of theta should be your y coordinates. I had that wrong whenever I made these notes the first time, which I know like the back of my hand, but I still did it wrong. And cosine of theta should be the x coordinates. All right. So I'm on a split screen here, and I'm going to pull up a copy of the unit circle, because you guys can put your papers next to each other and look.
I actually don't have that. I have 7.2 or sector.
I've got an extra. Let's see here. Alrighty. So let me pull up a copy of the unit circle. And I told your neighbor to double check you, but you know, like when you get home today, if you're still feeling a little shaky, like maybe you copied something wrong, just Google unit circle, and there's a gazillion. I like to go to images for it because that is easy to look at, but you're just going to have your unit circle sitting beside you. And tomorrow you can use your unit circle on the quiz. So you can have it sitting right there for you. You don't have to have it memorized until Monday. And that memorized, really, you don't have to memorize a lot of it, just parts of it. So what we'll be using this for is evaluating values using the unit circle. Now, you can do this on your calculator. I can type in sine of 45 degrees. Now, there's a couple things that will mess you up if you do this. Number one, it gives you a decimal, and I'm not going to accept decimals. I've got to have the exact value. So you're going to have to know the exact value. Number two, you've got to be in the right mode for the calculator, which a lot of students get mixed up switching back and forth from degree to radian because they'll be all mixed together. So, like right now, I'm in degree mode, so this is giving me the correct answer, 0.707. But I would have to type in these to see which one is 0.707. Now, I probably wouldn't have to type in much, really just the square root of 3 over 2 and square root of 2 over 2. I think it's square root of 2 over 2. I already know what that one is, but square root of 2 over 2. So, I will allow you to use your calculator. I will say to whenever you fill this in, you are going to be limited on time. I'm going to give you probably 10 minutes. You should be able to fill it in 10 minutes. So if you're having to rely on the calculator for every single point, you're going to have trouble getting it done that quickly. My pre-cal students could do it in under 5 minutes, pretty much the whole class. So 10 will be, I think, a gracious plenty to do that there whenever we're talking about filling this in. So, all right. But tomorrow, oops, I didn't mean to do that. All right, so tomorrow, here is what you will have your unit circle. All right, it will be given to you. And if you want to find sine of 45 degrees, you're not going to use your calculator, preferably. You're going to use your unit circle. So to use the unit circle, here is what you will do. You will find 45 degrees on your circle. that should be on the inside of the circle. That's where your angles are at. So it's in degrees, so I'm looking right here at 45 degrees. And then that means I need to look at this point that goes with my 45 degree angle. Right? So I'm finding my angle. I'm going to that point that goes with it. Is sine my x-coordinate or my y-coordinate? It is my y-coordinate. So my y-coordinate right here is square root of 2 over 2. Okay? So the answer for this is square root of 2 over 2. Okay? Let's do another one. Okay? This time it asked me for 150 degrees. So on my unit circle, I'm going to 150 degrees. It is right here on the unit circle. I'm going to look at the point that goes with it. Right there. This time I want cosine. So do I look at the x-coordinate or the y-coordinate? X-coordinate. So I look at this x-coordinate right here. It is negative square root of 3 over 2. So it equals negative square root of 3 over 2. And that would be my answer. So really you're just pulling these answers off of here. You have to know where to look and which coordinate to pick. Alright? Anybody think that they can do the next one? Negative 1. That is correct. Right? We're going to look at 270, which is right here. That means we got to look at this point. It's sine, so we look at y coordinates. So we get negative 1 for that. Okay, questions so far?
This is all the quizzes?
Yeah. We are going to have a few that are, we got to get coterminal angles for, but yes. So while the circle might seem super confusing, using it hopefully is not as confusing. All right, let's go to the next one. All right, I'm going to do the first one for you because I haven't done any with radians, and I'm going to let you guys try the rest of these. So radians, I've got sine of pi over 6. So that pi over 6 is my angle, right? It's right here on the unit circle. So you'll either have radians or degrees. You'll find that on the circle. Your answer, though, always comes from the point out here on the edge. And so this one is sine, so should I look at y-coordinate or x-coordinate? Y. Y-coordinate right here is 1/2. So 1/2 is my answer. Okay, does this make sense? Yes. For the points that you're looking at here, like I'm going to just use this one right here because it's just easier to draw. The first one is your x-coordinate, and that x-coordinate always tells you the cosine. And then the second coordinate, just like, because it's just coordinates like you would graph, right? So it's an x and a y. The y-coordinate here, that is your sine. So whether it's sine or cosine tells you which one to look at, whether you're using that first coordinate, the x-coordinate, or the second coordinate, the y-coordinate. Okay? All right, so try these on your own. I'm going to do them up here. And see what we get. it should, yes, number 12 copied badly. It should be 7 pi over 4. It looks right up here on my screen, but the 4 got slid over whenever it copied. I must have fixed that after I had already printed it. Alright, check with your neighbor, see if you're getting the same thing as them. Here are my answers. I think I did them right, but double check me, because I am definitely not perfect. Alright, any questions on those? Is that making sense? It's going to get just a little bit more difficult. Just a little bit, but not too bad. The next thing we're going to see is I'm going to give you some of these same problems, but they're not going to be values that are on the unit circle. So, it's going to look like this. I might ask for something like cosine of negative pi over 2. Or cosine of negative 405 degrees. Now, negative 405 degrees is not on this unit circle. So, what you have to do whenever you get something that's not on the unit circle is you need to find the coterminal angle, right? So, we have already done coterminal angles, right? For degrees, if you want to find a coterminal angle, what do you have to do? Add or subtract 360 degrees. And you're just going to add or subtract 360 until you get something that is on the unit circle. So for example, for number 16, that is negative, so I know I need to add. So I'm going to go to my calculator. I'm going to do negative 405. I'm going to add 360. It's not enough, right? It's still negative, so I'm going to add 360 again, and I get 315. So, because they are coterminal, they're going to end up at the same spot, and they're going to have the same value. So, cosine of 405 is the same as cosine of 315 degrees, because they end up in the same spot on the circle, right? So, cosine of 315, I'm going to go to 315. I'm going to look at this coordinate right here. That is cosine, which means I want to look at the x coordinate there. So I would get square root of 2 over 2 would be my answer for that. So if you get a number that's not on your unit circle, then you just have to find the coterminal angle that goes with it that is on the unit circle, and it's going to have that same value. With degrees, it's not too terrible because you're just adding or subtracting 360. It is a little harder with radians because you got fractions. So with radians, though, what do we do? Add or subtract 2 pi. So, if I want to know cosine of negative pi over 2, cosine of negative pi over 2 is not on the unit circle. So I am going to have to add or subtract 2 pi until I get something that is on the unit circle. Since it is negative, I know I want to add 2 pi. So I'm going to do negative pi over 2 plus 2 pi. And that is like 2 pi over 1. And I must have common denominators to add fractions. So I will multiply by 2 on top and bottom there. That will give me negative pi over 2 plus 4 pi over 2. And that's like a negative 1 pi. Negative 1 plus 4 is going to give us 3 pi over 2. Now that is not your answer, that's your coterminal angle. So cosine of negative pi over 2 is going to be equal to cosine of 3 pi over 2. And cosine of 3 pi over 2, I can go over here on my unit circle here, and we can do 3 pi over 2 is right here. We're doing cosine, so we got to look at that x coordinate. It is 0. Perfect. Now, I'm going to tell you about something. If you are more of a visual person, okay, this is how I usually look at it, and I like to avoid doing this like fraction stuff over here. So if you're more of a visual person, negative pi over 2, what did we say about negative angles? What direction do we go in when we have negative angles? They are clockwise, right? We go counterclockwise for our positive angles. So the way I think about this is I don't do the math over here on the side. So if this makes sense to you, you can do it also. If it doesn't, just do what I did over here first, right? So pi over 2 is that far in the positive direction, right? So negative pi over 2 is going to be that same distance, but in the negative direction. So rather than actually like adding and subtracting 2 pi, I just look at it. And I say to myself, pi over 2 is this far in this direction, so negative pi over 2 is this far. So that's the same as 3 pi over 2, 0 is my answer. So if that makes sense to you visually, you're welcome to do that. If it doesn't, you can just do the math over here on the side. I have some students that see this so well and others that don't, but this math can be your backup if you don't. Everybody good there? Okay, let's do a few more that are not on the unit circle. And here. Alright, so this whole page is full of ones that are not on the unit circle. So I'm going to do one with radians, one with degrees, and I'm going to let you guys try the others. Negative pi over 4 is not on the unit circle. And since it is not on the unit circle, I need to add 2 pi to it. Can anybody, so let's see if I've got any visual people out there. Can anybody just picture it and tell me what's going to be the same? What do you think, Miles? Yes, which angle are you looking at? 315, right? Which is 7 pi over 4, right? So without doing the math, if you see it like that, you don't have to do what I'm doing here on the page. Now, if you're like, oh, she must be a genius because I have no idea what she's doing, let's just do the math, okay? So we've got negative pi over 4 plus 2 pi, because 2 pi is a full rotation and is going to get us a coterminal angle. So I'm going to put that over 1, because to add fractions, I need them both to be fractions. I need the denominators to be the same, so I must multiply by 4 on top and bottom. And I'm going to get negative pi over 4 plus 8 pi over 4, which gives me, that's a negative 1 plus 8 is going to give me 7 pi over 4. So that means sine of negative pi over 4 is the same as sine of 7 pi over 4. So 7 pi over 4, I'm going to find it on my unit circle. There it is. I'm going to look at this point. Sine, which coordinate do I have to look at? Y coordinate. I should get negative square root of 2 over 2. Okay, questions on that? Degrees are so much easier because for degrees, you can just subtract 360. So we got 570 minus 360 is going to give us 210. So 210 is on the unit circle. So I can just flip back over here. This is going to be the same as cosine of 210 degrees, which if I look at my unit circle here, 210 degrees is right here on the unit circle. My calculator to get all the way here. Oh, no, didn't mean to do that. There we go. And I want to look at this point. Sawyer, for cosine, should I look at the x or the y coordinate? X. So right here is negative square root of 3 over 2 as my answer. Okay. Questions so far? All right, try those other ones on your own, and then we'll check and see how I'm doing. And actually, those are like everyone on this makes it go just so you don't have to do fractions, but it's since they passed on fraction. And then but you may have to subtract a little bit of time, 6 passes. Check with your neighbor, see if they're getting the same thing as you.
That's right. Do that.
Yes, perfect. I think, let me double check your,
You do the, you make.
that is a negative, correct?
Yeah.
Yeah, that was good. Alright. Okay, check with your neighbor, I don't know if you guys have checked yet, look at their paper, see if they're getting the same thing as you. Alright, some of you have not checked yet, but here are my answers. I did not show all my work on finding my coterminal angles, but I can show that to you guys if I need to. But if you're getting the same answers as me, probably you're. Hopefully. Now it is, you only have a limited number of answers for this. Your answers are 1, 0, 1/2, square root of 2 over 2, square root of 3 over 2, or the negatives of those. So sometimes you get lucky, I guess, but. How are we doing? 19? For 19, 19 is easier, which makes it seem harder because it's not the same. So 8 pi is too big, right? It is bigger than 2 pi. So we have to subtract 2 pi. You don't have to turn this one into a fraction because your original is not a fraction. So when you do 8 pi minus 2 pi, you get 6 pi. Still too big, right? So we want to do 6 pi minus 2 pi. And that's going to give us 4 pi. But that is still too big also. And then we've got 4 pi minus 2 pi, which will give us 2 pi. Which actually, like you may already know that's the same as 0 because if you go all the way around, that's 2 pi. But if you want to, you can subtract one more time. And 2 pi minus 2 pi just gives you 0. And so 0, you will look at 0 on that unit circle right here. You'll look at this point right here. And cosine is your x coordinate. So you'll get 1 for that. Okay, other questions? 22 is a little trickier because you got to add twice for that. Which one? Isaac, did you have a question? You figured it out, okay.
I got square root 2 over 2
For which one?
22.
22. You may have looked at the wrong spot because, like, any of them that end in 6 right here, even if you weren't looking like at the right spot, any of them that end in 6 are going to be like square root of 3 over 2 1/2. So you probably, did you have 11 pi over 6?
Yeah.
Okay, so you probably just looked at the wrong spot on your unit circle because, which we might double check, look at 11 pi over 6.
Well, I was using that one. So
Yeah, and make sure you got square root of 3 over 2 and negative 1/2 there for 11 pi over 6 for that. For 22, you have a negative, so we need to add 2 pi to get something on the unit circle. But the problem with this is when you do, you're going to have 13 pi over 6. We will add 2 pi, which is, we got to make it a fraction. we got to get common denominators. So we will multiply by 6. And so we will get negative 13 pi over 6 plus 12 pi over 6. And when we do that, negative 13 plus 12 is negative 1 pi over 6. Still not on the unit circle. So you're going to have to do that again. So it ends up being negative 1 pi over 6. Your 2 pi over 6, the same thing's going to happen. It's going to be 12 pi over 6. So you're going to add 12 pi over 6, and you will get now 11 pi over 6. And that will be your, that'll be your angle that you use. So you'll go over here to 11 pi over 6 right here. You're looking at this point, and it's sine, so it's the y coordinate for that. Okay. So sometimes, whenever you add or subtract 2 pi, you still don't get something on the unit circle. So you have to do it again for that. Okay, questions? All right, so I have a worksheet, and in second period, we made it a challenge. So we're going to do it here too. So don't start on it until I tell you. You guys are going to work on your own. You may use your unit circle.
Would you be mad if I printed one out? Like I'll let you look at it to approve them.
It's got to be handwritten. It's got to be a handwritten one. So now, if yours is messy and you would like to do another one, I can print it.
Yeah, I might need to do that. It's not like I understand it, but I need to handwrite rough.
Yeah. So let's say tomorrow you got to have a handwritten one. It's got to be one of these I've given you. But if you, I might have a couple extra here. I can go print some more if you guys, if yours is too messy. All right. So you got 20 questions here. I'm going to give you guys like 7 minutes to do as many as you can. Did you guys have an extra? Sorry about that. You're going to do as many as you can in 7 minutes. You are not working with anybody else. You are just working by yourself. You and your unit circle are going to answer these questions. You may use your calculator if you need to. Okay? So, whenever we are done, we're going to trade our papers and grade like we're in elementary school. And the top 3 with the most correct will get a late worker bathroom pass. Stakes are high. So, begin.